Who will survive Betelgeuse 2023 explosion? Normally we think that our sun is an extremely gigantic celestial body, but as compared to other stars in the universe or even in the galaxy, our sun is very tiny. These stars usually have a very dramatic end, and it's a very gorgeous spectacle. In this video, we will talk about the red Joust superstar Betelgeuse, which is likely to meet us end very soon. But this would result in a huge explosion, which may or may not affect our solar system. Stay tuned to find out what will happen during the Betelgeuse explosion in 2023. But before we continue further, I would request you to subscribe to the channel. Thank you. Recent news from NASA has indicated that there has been some rather unusual pulsating light from Betelgeuse. These pulsating light sources may be an early sign of the star's demise and an impending supernova. However, more interesting questions are if life on Earth would be affected if Betelgeuse explodes. So the last time when a supernova was visible within the Milky Way was back in 1604. There may have been more supernovas before that as well, or even after it, but chances are that these weren't visible due to atmospheric gas and dust. Crab Nebula exploded in 1054, and its light was first seen as a supernova on Earth. We have also observed other supernovas too. For example, in 1987, we saw a supernova in the Large Mag Clouds, which is located in close proximity to our Milky Way. We have seen supernovas take place in other galaxies too in some recent years, which are now observable through telescopes, but cannot be detected in Kepler's time. Betelgeuse began to dim in the later part of 2019, which led to speculation all across the world. People were expecting that the star would soon collapse. However, Betelgeuse has not collapsed since then and has even recovered some of its lost brightness. However, scientists are sure that the brightness of Betelgeuse could begin to dim at a later time. This has not stopped people from asking why it started to dim all of a sudden. Data collected from NASA's Hubble Space Telescope and other observatories revealed that Betelgeuse blew its physical top in 2019. This means that a surface mass ejection took place in which a huge chunk of its surface area was lost. This may have resulted in a hot gas enveloping surrounding stars, which may have caused the dimming of its light in the first place. Betelgeuse is estimated to be some 640 light-years away from Earth, but we are not very sure since other estimates put it quite some distance away from us. The issue is that estimating distances to red supergiants can be problematic. But no matter the distance, it is 100 times brighter than the Sun, and maybe because of its brilliance, it will soon run out of fuel. The reason is that when so much energy is expanded, the reserves of helium and hydrogen run out, leading to heavier elements under the weight of these heavy elements. The star explodes and we will see a supernova. But will we experience some effects on Earth of Betelgeuse supernova too? Scientists say that we may see some faint light, which is the result of a super hot, newly revealed core of the star. This diffused and somewhat bright light, but gradually dim over the period of 2 or 3 years. That is the estimated impact that Betelgeuse supernova would have on Earth. However, if Betelgeuse was any closer to us, then we may have been experiencing something different. Scientists estimate that if Betelgeuse was as close to us as Capella, which would be a total difference of 43 light-years only, then Earth would be exposed to very powerful electromagnetic rebirths, which would wipe out the ozone layer. Scientists estimate that ozone levels would be reverted back quite soon, but there is some threat associated with exposure to dangerous amounts of electromagnetic radiation. Thankfully, in our Milky Way, supernovas take place once every 50 years. However, sitting 159 light-years away, there is a binary star which could potentially produce a very cataclysmic supernova, since the star is a Type II white dwarf in which matter would dance around two very close stars. Thank you for watching, and don't forget to like the video and subscribe to our channel for more videos. And see you in the next one.